Welcome back to the Glasscast podcast and blog series from the National Glass Association and its leading publication, Glass Magazine. Once again, I'm Katie Devlin, Content Director for the NGA, and I'm here with my colleague, Sarah Neiswanger, NGA's Associate Director of Industry Engagement.
Thanks, Katie, and thanks again to all who have been tuning into our previous episodes. If you haven't heard the first three, they feature the panelists from the 5 Ways to Address Generational and Mentorship Gaps session, which took place at the 2023 BEC Conference held in March in Las Vegas. I encourage you to go back and check those out.
So for today's episode, we are going to be moving to highlight a different session from the BEC. This one was called We Will Overcome the Before, During, and After of Addressing Business Challenges. And during this session, which I should mention was moderated by our fave industry expert and podcast pro, Max Perelstein, we had 3 glazing contractors who opened up about some real-world challenges that they faced recently. It ranged from some scheduling hurdles to estimating problems, conflicts within the design team, and then one pretty eye-opening issue related to regulatory approvals.
This session really became one of the more talked about presentations following the BEC conference. It offered some on-the-ground strategies for addressing challenges that are certainly not unique to the 3 companies featured on the panel, but may be less talked about. The outcome was highly relatable, maybe a bit of fresh air even. Our participants were willing to address some of those frustrating nuances of a project at different stages and with different players. So today's episode will feature Matt Kamper, Director of Pre-Construction at Woodbridge Glass. And Matt takes us through a recent complex and custom curtain wall project where the glazing team came into conflicts with the design team over the plans for the wall system.
Yeah, I really appreciated Matt's willingness in his presentation to just go in depth on some of that back and forth that Woodbridge faced on the project. I mean, it's a pretty phenomenal job, and they did some really exciting problem solving and just general terrific work to bring it to fruition. But it, of course, was not without its challenges. Glazing contractors are increasingly taking on more complex jobs. And that means more delegated design assist, more BIM modeling, potential for site coordination issues, fabrication and installation challenges, kind of anything running the gamut. And I imagine that complexity makes such conflicts between project team members potentially more common. So with that, let's hand it over to Matt.
So I'm going to take a slightly different approach, and I'm going to talk about kind of the relationship side. And the first panel talked about getting the glazing contractor in early, trying to define parameters, data, expectations. And what we ran into wasn't necessarily the regulators, but some members of the design team who kept rejecting, saying, no, you're going to do it this way. And so we had to overcome that perception that we were incorrect. We had to prove it with math. And what it's going to come down to is we were proven in proof of concept at the end, but really we had to protect that ego and what we started with was talking about backlog and the perception. You didn't have the upper floors completed. And they were like, what's wrong with Pioneer? Because perception is going to drive our success and the next job we can win at times. And so in the same way, we had to do it once we were under contract, before we even started construction. We really had that struggle with the team accepting our concept and allowing us to even take the risk of doing it wrong. So for us, Woodbridge Glass, we're 2 companies. We are a fabrication, manufacturing, and installation. I work for Woodbridge on the installation side. So again, more installation focus versus fabrication or regulatory, as Dave said. So this was Anaheim Regional Transit Intermodal Center, ARTIC for short. And what that is an ETFE pillow curtain at the 200,000 square feet at the roof, allowing daylighting, allowing light in. We had the bookends. So we had a custom cable supported structural glass wall, and you'll see some details here in a second. But the project itself was meant to be light and open and bring the outside in for the comfort of the users. So quickly, I'll go over the project, talk about the construction progress pictures, system details and some explanation, the cable tensioning, which is where we had lots of tension, both politically as well as physically, and then some of the lessons learned. And so again, Arctic, I'm going to focus on the blue. That's the north elevation. So that same scheme is about half the size on the back end of the building. So the building from the inside looking out, again, talked about daylighting. We did this project, it is in Anaheim, and we did this in 2014. So the project today, there's a bridge that is actually coming from the train station, and what you don't see off picture to the left is both the Ducks Stadium, and across the street is Angel Stadium. So you have both a baseball venue and a hockey venue, both fed by this same station. And you can see the daylighting coming through, so the idea was the inside coming in. So this was one of our first projects. So the first thing we had to overcome was BIM. So it was one of our first complete BIM projects. So from soup to nuts, all the way through, we were designing from BIM, actually drawing, converting to Inventor, converting into fabrication, and then to job site installation. So for us, we had to overcome first the fear and the challenges. And I would dare say the gentleman next to me, their companies probably have a lot more experience in history with BIM and the modeling. We were newcomers in 2014. And this was our first time cutting our teeth. So we definitely had the struggles at the very beginning of having to reach out to experts, having to pay a premium for people with BIM experience, because from an estimating perspective, you can't put traditional engineering monies into a job like this, especially not the first time out of the gate. So first lesson learned there was we were short on some engineering monies, because as the estimating team, we underestimated the level of complexity, the level of ingenuity that was needed, and the number of hands that needed to touch the BIM modeling. The second thing we had to overcome was, and I'm sure this has never happened to anyone here, but the steel wasn't where it was supposed to be. In fact, it was off by over 9 inches. And so we were given guaranteed dimensions. We went to field verify. We 3D Hilti scanned, and about 60% of the clips were wrong. They were out of where they should have been. So we had to go back through, force some changes, which nobody wanted to pay for, and again, modify the model. Proof of concept, you're out of our model tolerances, here's where they are. And so the coordination led to a reconfiguration. Like David said, you've really got to plan your field logistics. We had to adjust that 3 times before we really got out there to make sure we could get it right. So this is an inside view as we started to erect. I'm going to go forward and then backwards. We then first erected the armatures, then we glazed the project. That is inside the work almost near completion. You can see we had a number of armatures. It was a vertical SSG joint system with a horizontally captured curve point. The particular challenge on this was that all of the system was supported with a tension cable that ran through the armatures and allowed for the structural support. So you can see our guys there on the outside doing the glazing. That's a horizontal capture with a vertical SSG joint. From the inside looking out, on the 2 sides, you can see the cable running through the armatures. That's a mid-span, obviously. And so the design portion of the calculations for how to support the structure, the overcoming portion of it was everybody focused on the cables, because they told us you may not pre-stress or pre-tension the cables. We said there's no way we're going to get in there and not pre-stress those cables and make them think that they're under load. And so during the design charrettes and prior to getting out to the field, we went through 3 different iterations of trying to prove mathematically that by pre-tensioning the cables, you would eliminate the need for missing joints. We were 1/8 of an inch over 40 feet. And so in our BIM model, we modeled if we don't pre-tension and there's these mistakes on these 3 or 4 cables, all of these things would be off and we wouldn't have the symmetry that you're looking for. So again, the overcoming side of it was first having to prove it to them intellectually, but then having to prove it to them physically on site. And so what we ended up doing is we ended up having basically a clevis system that we attached up at the roof. We had to start top down, middle to go right and left. And so what we ended up doing is actually having to run the cables. There's a gentleman at the bottom, 3 gentlemen up on the booms. We would tension the first cable for the first area, the first zone of this armature, test it, record it. Then we would go to the next cable, tension it, and record it. So we had some temps in order to look at levels. Essentially, had a level that we were watching so that at that same zone, that same level, so we had 3 armatures at the very top, we first made sure that they were level before we even touched it with glass or installed anything. Well, going back to the overcoming, the estimate, we did not have the labor for that level of touch and come back touch. We had 3 mobilizations. We planned for 2. So again, it's that lesson learned of
We didn't anticipate at the estimating level, even though we tried, even though we were in design assurance, design assist, we still miscalculated the amount of field labor and time it would take to get these true form level before we actually even did our job. And you look at Master Chef, they're always prepping food, and if the meats don't get cooked, the whole thing's horrible. Well, in the same way, we tried to avoid that, and at the end of the day, we actually ended up having to go into the system at the midspan, and we ended up, instead of having just basically a clamp attachment. So we put all the stress at the top and bottom of the head and the sill. On top of that, we had no testing. So somewhere Dave had to deal with the regulators saying testing. This was a completely custom system. So we got down the road, all you need is a visual mock-up because we were going to do on-site in situ testing. Oh, no, you need to do a mock-up. So same thing you experienced, you throw your schedule out, no money for that. So we had to immediately adjust while progressing with the design and progressing with our concept. At the bottom, and I know it's not easy to see, but there's a big spring. You look tight. There's a big spring right at the bottom and a nut at the bottom. Once we had all of them pre-tensioned properly, we secured that nut so that they wouldn't move. And jumping to the end, we had the middle cables moving 4.5 inches by pre-stretching, and the smallest cables only stretched 3/4 of an inch. So there is no way, had we done it on site and stretched them post-install, that we would have been able to finish the project at anything true plumbing level and kept it specified 1 acre or 40 feet. We had to test the cables. So I think if I push the button, it'll run. And try it. Okay, the video. Yes. Here you go. It's going to be loud, just let you know. Nope, it's 28 seconds. There it goes. Okay. So we, as part of our testing, were required to actually take the failure of the cables. So we went through a number of different cable sizes, thicknesses, because of course they wanted universality in the thickness of the cable, so we had to design the cable for the worst case scenario. And so we went through 15 or 20 different of these tests, destructive tests, to find out how much we could tension the cables, how far they would pre-stress. We did it with different lengths, and so this was just a destruction. But our testing chamber was actually 25 feet tall, and we had to stretch those cables, because just because you stretch it 6 feet is going to be the same stretch, the same parameters as going 20, 25 feet. And just to give you perspective, this is a 126-foot long cable, was the longest cable we had. And so at the end of the day, the overcoming side of it was convincing them that our proof of concept was correct, that we needed to pre-stress the cables. The problem was, again, you had egos involved. And no, you don't. I'm right, you're wrong. And so we had to overcome the perception, we had to overcome the egos, we had to overcome the financial side of that with the misestimating monies for the time, the application, the field labor. But I think at the end of the day, it was a good project for us, a great learning lesson, and again, BIM, fantastic. So quickly going through, you'll get these slides. Still was a challenge. I mean, locations were exceeding the anticipated tolerances. So we had to refab, even fab sometimes. We had a second shift, fabbing at night and shipping the armatures out at 2 in the morning so they could be reinstalled the next day. So there was a lot of that just flexible engineering back and forth. The cable modules and elasticity, talking about learning and talking about how we've never done learning in this industry. We learned a ton about cable modules, so the elasticity of cables, what they do and why they do it. If you ask me today, have we ever done a cable job? The answer is no. Would we? Maybe. So, materials. They were added components, added elements, the welding in the field, the special inspections. Again, going back today, we had a ton of special inspections, so we wanted full pen welds. And anybody knows a full pen weld, it's a lot more time and money than just another type of tack weld. So we had to do full pen welds and have every single one of them analyzed because it's a government project. And so we had a ton of time to just wait for the inspectors. Guys are down there drinking coffee while the inspectors are up checking all our welds. So a lot of that layer upon layer. Design and engineering, again, a lot of pre-tensioning, a lot of the newer processes in order for we can even get on site. BIM, I mentioned BIM. Last thing was schedule impacts, and of course, as we all know, we were late. Because steel was off. But we were late. So we ended up making up schedule, we ended up putting a lot of overtime. We got TCO on time, and so the silver lining is we finished it, and thankfully it did win several awards. It's a tremendous project.
Many thanks again to Matt Kamper for providing an example of how Woodbridge Glass navigated the complexities of the Anaheim Regional Transport Center. Tune in again for our 5th episode of Glasscast to hear from David Ferret of Bagatellos Architectural Glass.
From the BEC, and of course, for all resources and updates from the National Glass Association, you can visit glass.org. Have a great rest of the day, and we'll see you next time.